Okay, what you have is, looks like a worksheet. Most of the time that I give you lecture notes, you'll have something like this in front of you that, that you'll just fill in as we go through it. But today, what I want to do is to go through this information and then us together go back and fill it in, okay? So the first time around, I want you to just listen to me, put your pens, pencils down, and then we will go back through this together and fill it out. So as I told you yesterday, that this week and part of next week, we will be looking at the scientific method. Scientific method is, it's a system or it's a list of steps or procedures that scientists use to answer questions or solve problems. And we use these same methods as well when we have problems to solve. So the scientists are trying to figure out a problem or they're trying to answer a question. Now, the steps that they follow, first of all, we've got to have a problem. We've got to have something that we're looking to solve. So the first thing, one of our first steps that we need to do is to state the problem. Most often, we look at the problem as a question, which makes it easier for us when we're moving through the scientific method. If we have a question that we're trying to answer, it helps us to look at it easily. Now, the next step would be to research and make observations. What we're researching is the topic or the concept within the problem. If our problem is which fertilizer helps plants to grow quicker, so what are we going to research in that? We're going to research fertilizers and what else?
Plants.
Yes, plants. So we're looking to research fertilizers, what fertilizers there are out there. We're looking to research what fertilizers actually do. And then we obviously have to know about plant growth. And do plants need fertilizers? How do plants grow? So there's a lot of information there. Observations also come into play. And later on today, maybe we're going to look more at two specific observations, which is qualitative and quantitative. And we'll look more at the definitions of those two. So we're researching and we're making observations. Our next step is hypothesize. We're going to establish or create a hypothesis. And what is a hypothesis, Divinity?
An educated guess.
Yes, an educated guess. And educated is important in that definition because what did you just do in the step before? Go ahead.
Research.
We researched, we made observations, we educated ourselves, so we are now able to make an educated guess about which fertilizers help plants to grow the quickest. So we state our hypothesis, and our hypothesis has to be something that we can test. So if we are determining which fertilizer helps plants grow, we may be looking at two different fertilizers. Okay, so we're testing one against the other. Then we have to come up with an experiment. We have to come up with a way that we can test that hypothesis. And as we're testing it, we're gathering information, we're gathering data, our results, if you will. So once our experiment is done, we have all these results, and then we analyze it. we compared the results to the two fertilizers. We looked at how we conducted the experiment. We look at every aspect of that experiment, and we're looking to determine which fertilizer helps plants to grow. Then the last thing that we're going to do is to draw a conclusion. Now, our conclusion includes a lot of things. One, it's a brief summary of why we conducted this experiment, what we're looking for, how we did it, but the most important thing that our conclusions should include is, did our results confirm our hypothesis? Did the results support the hypothesis? If we hypothesize that fertilizer A works better than fertilizer B, then in our conclusion, after our analysis of the results, we have to state if our results supported that particular fertilizer. If it did, if our hypothesis was fertilizer A is better than B, and that was in our results, then we can confirm fertilizer A was right. My results show this. But if it doesn't, if our results do not support our hypothesis, then we need to take a really close look at our experiment. We may even need to make some changes and do it again. So that is scientific method in a nutshell. I didn't go into detail on all the factors. We'll look at that tomorrow that is associated with that. But that's a brief overview of the scientific method. So let's go back and fill in our sheet. All right, what is the scientific method? The scientific method is, tell me.
When you have a problem, you research it, then you make a hypothesis, then you experiment, and then you receive the results, and then you make a conclusion.
That's good. Now, what I want you to jot down is the scientific method is a series of steps or procedures